Hey guys, I hope all of you can see me, can see my screen. If not, please use the chat. I will be monitoring the chats in between of the session. So hi, I hope everything went well connecting to this. It's a bit new doing this through the digital world. I'm just gonna start, and I hope everything goes well. Yeah, cool. All right, so this webinar, Kubernetes from Zero to Hero. It's an introduction to Kubernetes. I hope all of you will get some benefit out of this. So quickly, before we start, I'm going to do some actual command line stuff with Kubernetes. You can follow along. On Friday, we've sent out some instructions on how to get it working. Of course, not every environment is the same, so there might be some issues. I've provided a script for AWS and Azure. Both of these don't assume anything configured for network and authentication. So if you have some special configurations regarding that, it might not work. So just providing this to help you out in case. This is the GitLab link, so it's my name / Kubernetes KISS. Right. So let's get starting quick. Who am I? So I'm with Dava team. I like coding. I like IT. I like everything around it. And I'm working for Dava team, as I mentioned. Basically, the gist of Dava team, I'm not going to do this too long, is that our playground is, well, Europe, Middle East, but specifically the cloud. We're partners with a lot of cloud vendors and a lot of focus on cloud. This is why we're here with Kubernetes. So, small plug for myself. We're in chapter 1, Zero to Hero, and then we'll start digging into various topics, which will be coming soon. The Enterprise Ready Kubernetes webinar for OpenShift is already scheduled for 18th of June. The rest of them will also be scheduled in the coming month. I'll keep you up to date through the email, but feel free to attend whatever you like, or what is your domain, or what your interest is. Yeah, so what can you expect today? I'm going to quickly give some theory, like how did we get to Kubernetes, what does it do, and how does it do it? And then after, we're going to actually do some demoing, which will take most of the time. I've got 3 sample applications, which are also in the GitLab repository. Quickly going to transition from Docker Compose to Kubernetes, then go through a few of the concepts which I found in my experience to be useful to understand, and make the foundation for what is to come with the other webinars. And we'll finish with some QA. I'm a little bit strapped for time, so questions, please fire them. I will get back to them if I have time in between things, or specifically at the end. Yeah, so let's get into it. Let's look at what Kubernetes is. Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitate both declarative configuration and automation. It has a large, rapid growing ecosystem. Kubernetes services, supports, and tools are widely available. So that's a lot, right? What am I going to focus on today is managing containerized workloads and services, declarative configuration, and tooling. Kind of gave that away with Docker Compose. So let's quickly zoom in on how did we get here. So I'm pretty sure many of you have seen this picture, but I quickly wanted to go through this to explain the buzzword Kubernetes. So many years ago, we did the very traditional deployment of applications just on an actual machine, on an operating system. And that worked well, but it was not that reliable. There's a lack of automation, and how are we gonna add another production, right? So we invented the virtual machine. It was a lot more automated, a lot more reliable, but it wasn't as speedy because you had to put up this hypervisor or leverage it, have an operating system, and then etc. etc. So now containers, which is speedy and very automatable, but the problem is when you're scaling, right? And you're generally going to do that with containers. You're going to scale. So how do you manage these thousands of microservices, services within your landscape? So that's kind of the why. At its core, it's an orchestrator. It's an orchestrator for containers. It came to be at Google. Google actually uses it internally for a long while because they had a gazillion of microservices, and they had to have something to orchestrate that, to manage that, to bring some order to the chaos. At some point, they thought, hey, this works really well, and let's open source this. Let's have other people benefit from our discovery. And it's since then been expanded upon by Red Hat in the form of OpenShift. Quick plug for my guys who are going to do the OpenShift webinar soon. So what does it offer you? This is a lot of stuff, right? Service discovery and load balancing. So it's going to discover all your containers and all your services which it gives, and it will load balance for you as well. Storage orchestration, it will manage storage and how you access storage and how all these containers access storage, because you can imagine you only have one disk and so many of these microservices. How are you going to manage that? Rollouts and rollbacks, which can be automated depending on your configuration. Releasing is a pain. We've all been there. It can hurt really badly, and some actual automation never hurts. It can automatically detect if things are not functioning well, hence the self-healing, and roll it back to a previous version which you would like. So as I mentioned, self-healing. Kubernetes can check how alive and how ready a pod is. You can define that yourself as well, and depending on that, take action. So if this container is misbehaving, depending on your configuration, Kubernetes can kill it and just bring up a new one. Finally, configuration management and secret management. So for your sensitive data, you have secrets. For your configuration, you have config maps, which are two concepts we're going to look at. And these are used to provide this configuration or these secrets to whichever container needs it. You can imagine that you would want to connect to a database with a username password. You don't want everyone to read that. Right, so how do we actually do this with Kubernetes? I quickly want to take a little bit more time to analyze what Kubernetes actually does, because when I started with Kubernetes, I was like, okay, this magic thing does things, but how does it do it, and what happens under the hood? So I'm quickly going to walk through that, which is the control plane, which is what you see on the left. So let's start with the Kube APIs server, which is basically the central point of pretty much everything from Kubernetes. It's the communicator, so it communicates with your nodes, with your scheduler, with your storage, with everything that Kubernetes has, but also with you as a client, right? You will type some Kube's commands into your command line, and they will go to the API server. So as I said, storage. Kubernetes utilizes etcd out of the box, and that's actually a product which is on the market for a while now, and its main strength is scalability, mission critical, fast stuff. So in that sense, it really matches Kubernetes. The scheduler, well, you want to put your workloads, right? We looked about the definition of Kubernetes, and it said workloads. Okay, so the scheduler schedules workloads on your nodes. I'll get into the nodes in a second. So then you have the controller managers. One specifically is the cloud controller manager. I'm going to talk about that in a second, but let's take a look at the controller manager as a whole. You have various controller managers. As you can see, there's not just one, and each have a specific task. For example, the replication controller. So you can imagine that you would want to scale one container numerous times over various nodes. And the scheduler just schedule it, right? But someone needs to tell the scheduler to schedule it, and that is the replication controller manager's job. There's various ones also for security, etc., network, etc. You can also write your own one, which is maybe fun, or I don't think it's useful for most use cases, but it is an extensible control plane, right? You can plug in your own controller managers. Finally, the cloud controller manager. This is often a collaboration between Kubernetes and said cloud provider. So for example, AWS. If you want to use the load balancing functionality of AWS, then you can through use of the cloud controller manager. So all cloud native things like storage, databases, and stuff like that, you can integrate really well within Kubernetes, again, demonstrating its extensibility. Then quickly looking at the nodes, each node has a proxy, which is responsible for traffic routing and stuff like that. And the kubelet is responsible for talking with the control plane. I'm keeping it dumbed down, but there's a lot more material to read about this, and I don't want to take too much time of this. So it's time for the practical side of things. I hope everything's going to go well. Praying here. If it doesn't, well, we'll just move on to the next topic. So I'm going to exit out of my presentation, move that to the side, and have this one for you guys. So as I said, the GitLab repository, it adds various stuff here, and it also has all the content. It will be updated a little bit throughout the day, so you can keep up there. So with further ado, I'm going to drag my command prompt interview. I hope you can follow along. I hope you can see everything. So let's go to the root of the directory. So I've cloned it here. Let's take a quick look. You've got some documentation. I've written out most of what I'm telling you guys now. You can reread it a bit. But for now, let's go into the practical side. And let's take a look here. So what we're going to do is go through these applications and actually work with them a bit. Quick run through the 3 apps. So you have a config map app. That is quite obvious what you're going to do with that. You're going to play with config maps. The environment variable, again, quite obvious what it's going to do. And the quotes app, which is a more full-fledged application, more of a very small use case of a workload which you could deploy on Kubernetes. Each of these are packed into a Docker container. I've put them on my Docker hub, so all of you can use it. I've done it on my server, on my account, but you guys could also do that on yours through the build and push all apps. You just define your Docker hub credentials, and it'll push it there. So you can update the applications and play along with them a little bit more. So let's actually get started with Compose. Compose is a tool which transforms Docker Compose files into actual Kubernetes definition. So why do I think this is important to highlight? all of us start off somewhere with the transition to containers, and Docker Compose is a quite easy to understand concept to start working with. I see a lot of dev environments locally being well, somewhat based on Docker Compose, which often leads to a problem, right? So you come to a Docker Compose file, which is something like this, which has just a few services. As I said, these two services, and they run, right? So we can do a Docker Compose up, and they will run. We define the image, some port mapping in the environment and the variables, all good. Now, our operation department decides to implement Kubernetes. And I'm going to show you exactly why Docker Compose then might nip you a little bit in the butt. And I will now leverage Compose to actually move from Docker Compose to Kubernetes quite easily, so that you can also work with Kubernetes. So I've booted up these two, and on your localhost you should be able to see localhost 8001/message and 8002/message. So as per the Docker Compose, one of them reads from an environment variable, the other one from configuration. I'm not going to configure this one with Docker Compose right now. I'll do that with Kubernetes after, which is the configuration app, as here. So find here. So okay, we've got this is working well. All right, let's actually get going with how to transform it. So let's clear that up. We can use Compose. And we can give it a file, which is the Docker Compose file, right? And we'll give it an output, which is the out directory output. Actually, I've already done this, but you can install Compose. It's very easy, and then run this. For your ledger, I've already done that in the output directory, such as here. If you now have your Kubernetes installed, let's quickly do that. kubectl get pods. Okay, it responds with no resources found. That's good. So it's up. So we're going to apply the entire directory by just doing kubectl apply -f output, which is quite simple. It will create a few things. And if we query the pods which are running, it will see that our apps are running. Okay, so a few things happened here, right? I'm transforming Docker Compose, which is pretty small definition of my containers and such, to Kubernetes definition, and all of a sudden it gets running. So okay, so let's take a step back. What is actually in the output directory? So from one file, we've created 4 files. Okay, so that's quite a hurdle. Let's take a quick look at the config map application. So it's already a decent sized YAML definition. And I quickly wanted to walk through this skeleton definition of a Kubernetes YAML file, so we can move on a bit quicker in the rest of the presentation. So there's 4 root level things, which is the spec, metadata, kind, and API version, which is relevant here. The API version is a versioning tool done by Kubernetes, so you can use the various version of a certain definition. The certain definition in this case is a deployment. Kind is deployment. Metadata then has, as it kind of says, some metadata. It has a name, you can label it, you can annotate it, stuff like that. And the real meat of the definition is in the spec. There's a lot of clutter here, and I hope you can bear with me. Such as the compose command, it shows how I converted it. the version, stuff like that. So right here, it says containers, right? And this is exactly the same as our compose file, right? This bit is exactly the same as our configuration here. So the image is exactly the same. So the name is the same, the container port is the same. So this is what we really want to focus on, this part. So it's going to deploy this image, and it's going to give this port on the container. The only thing what you might miss here is the actual exposing, which we did in the Docker Compose file. And this is something I find is often a problem going from Docker Compose to Kubernetes. Is the actual basic networking is a lot different in Kubernetes. So let's zoom in that problem in a second. Again, there's another deployment YAML for the environment variable, but there's also two services. And I quickly want to talk about the kinds now. So when I went to the command line, you saw pods, me querying pods. And pods is also a kind which you could define, which is the bare, well, it's the smallest thing in Kubernetes which we can wrap our heads around. It's a definition of one or more containers which run as a single deployable unit. You can scale this up and scale this down, and you can play around with it. But the interesting point is that it can contain multiple containers. I'm not going to zoom in on that now, but you can do some quite nifty things with that. Now then, the obvious question is like, why is this a deployment? So deployment is a wrapper around the wrapper of a pod. So to confuse you a little bit more, so you have a pod, which is then controlled by a replica set, which contains the definition of replicas, right? So imagine you want to scale up your pods. You want to have this application multiple times. You can tell the replica set, I want more. So it will do that. It will create more pods. And deployment is a wrapper around the replica set to, well, even create multiple replica sets across multiple regions, etc., etc. It does more than that. I'll not dig into too much of what the deployment can do apart from that, but it's basically a orchestrator of your applications. Right, so as I said as well, the networking part, let's zoom in on that. So this is where the service comes in. The service is the most basic networking construct which we have in Kubernetes. And here you can actually see what we expected is that the port 8001 is mapped to 8080. So in the deployment, we say, hey, this container exposes 8080, and here we map it. Now, you would expect to be able to go to your Kubernetes node and actually go to 8001/message and get the same output. Well, you'd be wrong, but let's quickly do that. So let me quickly do get nodes. My setup is running on AWS, as you can see. So it's no longer on local, it's on AWS. I'm using version 1.16 for those interested. And I've got it configured so it's publicly available. Please, if you are trying this yourself, make sure that your security groups and stuff like that are configured correctly. Same goes for Azure. I don't know how your account is going to be set up, so I don't really want to assume. I hope that if you're using it, you are aware of what you need to do. So let's go to this IP address and go to the port 8001/message. And it's refusing to connect. This is the problem I run into many times when when I see people go from Docker Compose to Kubernetes. Why doesn't this work? So let me quickly answer that question for you. I've already given the answer in the updated services, which is also a stripped down pod. So let's quickly take a look. You can specifically see the type here. So again, kind service, and this spec is the actual definition of the service. So here the type is different. We have various types of services. So the default value is cluster IP, which means that on the internal cluster of Kubernetes, it is exposed on a certain port. That is not what we want. We want to access it from publicly, right? We want to expose our service. So there's a few ways to do this. Node port is one of them. So it kind of says that on the node on which the Kubernetes container is running, it exposes the service on a specific port. Now, this is what I define. Port name, again, it's 8001, but it's no longer 8001 because node port says 3001. Target port, again, is 88. So if you look at this, and I hope it works. Oh, hold up. I didn't apply it. So let's apply the updated services. Kubernetes will apply these services, and we can query these as well while they are getting applied and stuff like that. So we can do get services, and we see them here. Again, it says node port now instead of cluster IP, like that. Other deployment we get out of the box. So now here's hoping, yeah, it works. And so this one now works, and the other one also works. Right, good. So we've done this for now, and we've exposed our ports correctly on the nodes. Again, you don't want to use this in production this way. We can dive deeper into networking because of the limited time. I'm not going to do that. One of the future sessions will. So if you're into more networking, please come visit us and then more networking advanced topics. All right, but let's move onwards. Let's actually demonstrate this this thing I talked to you about deployment. So I'm going to watch our pods and see that we have two of these pods running. Now, the environment variable application will have to be updated, right? So we want to update our environment variable. Let's quickly go into the directory. I've already updated the environment variable here in a new deployment where I've defined some environment variable for this container. The app envar is Kubernetes. The application will read this envar. So we want to apply this. So let's do that, right? kubectl apply f and then updated env. Let's take a look at how Kubernetes is actually going to do that, because we're going to upgrade a deployment, right? So when I do this, you can actually see this going quite quickly. The environment variable goes from a running state to a new one being created with a pending state. It creates the container, it says running, and afterwards the other one is going to be terminating. So it realizes, okay, you have a new version of this deployment, and I would like to have this deployed, but I wouldn't like to have downtime. I would still like to have my clients use my applications. So what it's going to do, it's going to roll out that new version and get that running. And after that is running, it will terminate the previous one, meaning no downtime. So let's take a quick look at the message. It's now Kubernetes. So we're hitting our new application deployment. Right. So let's clean up. We've done let's recap. We've done a small demonstration of moving from Docker Compose to Kubernetes and got it running on the node. So this demonstrates a little bit of the services, a little bit of the pods, and of the deployments. I already gave you a spoiler that we're going to look at config maps, so that's going to be next. Quick intermezzo. If you have questions, I'm still going to run quickly through it. The GitLab link is good. You can also do it in the chat. Feel free to reach out to me. My contact details will be at the end of the presentation. Right. So let's clean up. Let's just delete everything, all of the things. As you can see, it removes the services, the pods, deployments, replica sets, all of it gone. So we can quickly check if that's the case. I'm just going to do this, and we just have the default service, which is Kubernetes. Okay. Let's now move over to the different folder. So we're going to go out of the compose folder and we're going to go into the config maps folder. I'm sorry for the name. It's not very well picked. But, right. So in this folder, we have two things. We have a deployment and a config map. I'm quickly going to show you the deployment, even though, oh, apologies, we've already looked at this. There's some other stuff at the top I'm going to look at in a moment, but this is the raw deployment. It's a lot more trimmed down. So as I said previously, Compose creates quite some clutter. It's not all needed. So we can do this pretty simply. So it names a namespace here, and I wanted to highlight the namespace concept a little here. You can imagine that you would want to not have everyone be able to mess with your deployments. You would want to have some kind of separation of your team and other teams, or marketing and sales and engineering, or whatever, how you want to structure your Kubernetes deployment. You can do that through namespaces. So you can actually query namespaces by kubectl get namespaces. So you'll get all the namespaces. This is the default namespaces you get out of the box when doing it on AWS. The one which you often see is actually the kube system. Now let's quickly take a look how to query that. So I'm going to get all namespace kube system, and voila, it will show you various things such as networking and metrics, kubedns, these kind of things. All right, so we can query different namespaces. So if we do get all without the namespaces, we don't see anything. Well, just the Kubernetes service, but apart from that, nothing. So we're going to do that here. We're going to apply the config map deployment. So as you can see, it creates a namespace, role binding, deployment, and service. I clustered these things together here because we already went over it. Most of the concepts, the role binding, it's a role access based thing. I'm not going to get into it. Do not use this example in production, please. This is a very, very, very simple example. So we defined our namespace here with the name. That's all. It's very simple. And in all of our other definitions, the namespace is set to A1. as an example. So the service, the deployment, all of it is set in A1. So if I kubectl get all, as previously, we will not get much. So get all namespace A1, minus n is short for namespace, we get what we expected. Again, the config map service is put on node port. It's still the same, so we can quickly check, that's the wrong one here. It's running, and it is. Again, this is a default message. So this is what's going to be next up, a config map. So I spoiled it many times already with the name and stuff like that, but there's also another construct that I would want to explain to you, which is config maps. So, okay, what do they do? Config maps, as they kind of already give away by the name, is that they can give properties, stuff like that. Now, the config map application is a Spring Boot application. Those of you who are familiar with it, it reads from application properties. So this is where we're going to give it a config map, and we would like to have it display this new name. Again, we can simply apply -f the config map. Again, sorry for the naming, it is pretty poor. Which we can query get by git config map and then namespace, and then again the namespace. So if we query that like this, we get it, right? We can also describe it a bit, which is a useful command from kubectl. And do that like this. When you get, oh, apologies. You do have to define the resource you're trying to describe. So the config map app. And it just gives me in plain text what it is. We're going to spoil something again. Next up is secrets, because not everything of these things we want to be able to show. Right. But anyway, let's hope the demo gods, yes. It updates the configuration, and voila, our application now defines our new message. So I hope that all goes well for you guys. I got a few questions about the networking using Node port. Node port is generally not used, or I would not use this in production. I would use the load balancer functionality of, for example, AWS to add AWS load balancing functionality to your Kubernetes cluster, and then leverage that instead of exposing Node port and then have a reverse proxy for it. I hope that answers your question. If not, please come back to me. Well, ask a question, whatever. Right. So again, let's clean up. So delete namespace A1. It will clean up the namespace and everything which it contains. So let's wait a second for that. So now we've done the two sample applications. Now let's move on to the third. I quickly want to introduce this. This is a quotes app. It basically gives you quotes. It needs a database, and this is where I already spoiled it. Secrets come in. Why? Because you want your application to connect to your database. And you don't want someone to just describe your config map and then see it, right? You don't want that, because then everyone can go into your database, and then you get into the news and nasty things all around. So how are we going to do that? We're going to do that from the quotes resources folder. Let's take a look at that. So the main thing here is a secret. Again, kind secret, and then we get some data here. As you can see, username and password, you might guess it's admin. Keep it very simple. But someone who might not know this can see that. So let's actually start applying these things. Again, there's a namespace to put that in. I'm going to apply that first. So kubectl apply -f quotes oh, I'm in the wrong folder. Apologies. Let's go into quotes resources. Kubectl apply -f namespace. So we want to first construct a namespace in our role binding to allow everything to work. Okay, cool. So let's apply a secret and see what actually is going to happen. Oh, sorry, database secret. And it's created. So let's use our describe command again. It is called db secret, and again in the namespace quotes in this case. And when I describe it, it doesn't show me what it actually is, right? So I cannot access these quotes, or sorry, quotes database secret like this. I'm gonna now leverage this database secret. In the deployment, I'm gonna use MongoDB, you can use whatever. Doesn't matter too much. I'm gonna expose it on the node port in case you wanna play around with MongoDB and change the quotes. Feel free, it's not necessary. So, apologies for that quick mute. So what is important here is the env, the init root username and the root password. It's a value from secret key ref. So we say this is the secret I'm going to refer to, and I'm going to use the key username to put into this. And the same is true for the password. So let's quickly kubectl apply Mongo deployment. So now it actually deploys the MongoDB database. So what I quickly want to tell you with secrets is, of course, I can't read them with that. Now, what I can do, and what you should be aware of when you're working with Kubernetes is when I go to the pods and I see my MongoDB service and in my quotes, see the logs of the MongoDB service, and I'm going to quickly copy, paste this. I will see the logs of this service. Now, I can see the user creation here. So meaning that you don't expose it in Kubernetes doesn't mean that your application doesn't expose it. Be aware of that. Right, so let's finish this up. We see the quotes app deployment, which is, again, a service node port 3003, 330,003, sorry, apologies. And again, a ref from the Mongo username and password to the database. So they're both going to utilize this secret. Again, applying quotes app deployment. And voila, it works. Now let's hope demo are with me. Yeah, voila. So now it retrieves some quotes from the database, and everything seems to be working there. Cool. So now we've tackled secrets. So you can do a basic deployment on your production environment, and you know how to handle some of it. Okay, now moving onwards. And what happens if we want to scale up, right? We've already said in the world of containers, scaling is important. So let's actually scale. Let's scale something. So I already talked a little bit about these things, but let's actually put this into practice. So let's get the deployments of quotes. We see both the MongoDB and the quotes. If we get a replica set of quotes, we see that, again, the quotes app has one desired, so does the MongoDB. This is important for how many we desire and what is the current and readiness of this replica definition. So let's actually scale the quotes app. So kubectl namespace quotes, and then we're gonna do scale. It's pretty simple. Replicas, let's say 5. Deployment quotes app. So we're gonna scale this quotes app to 5 replicas. It says, okay, I scaled it. Well, let's see if that we believe it. And it says that it has 5 ready enabled. So okay, let's quickly look at our pods. How does that go? And as you can see, we've got them up and running just like that. Again, this is why Kubernetes allows us to scale really well, and this is why Kubernetes is a little bit of a buzzword. Okay, but I manually intervened just now. I generally don't want to intervene when the load goes up. I want the system to be smart enough to do that. Kubernetes is. I've not crafted the next example myself. So if it breaks, then it's not my my doing. No. There's a very beautiful blog about autoscaling, which I'm going to leverage now to demonstrate to you. Okay, how are we gonna do this? So first off, I'm gonna delete the namespace quotes because we are no longer needing that. And I don't want 5 of these apps to be churning at my AWS bill. Right, I need 2 consoles for this. And so I'm going to copy paste a few commands because they're pretty extensive. I'll run through them with you in a second. Let's wait for that. Quotes namespace, there we go. So we're gonna run a image, or sorry, we're gonna run PHP admin Apache. I personally I'm not too fond of PHP. I'm gonna demonstrate why. I'm gonna give it a certain amount of CPU and memory and expose it on port AC. It creates a service, etc., etc. For this, I'm not gonna show the web page. I'm just gonna solely work in the command prompt. Okay, so we want to autoscale this, right? Autoscale, as you can expect it. Deployment, which is gonna say we want to autoscale this deployment PHP at Apache, which we've just defined. And then we just say what we want to scale it on, and which is the CPU percent, which is 50, the min and a max. So we want our CPU percentage across the board to be roughly 50%. And we're telling Kubernetes that the min and max of pods he can work with is the min of 1, because we want 1 to be available all the time, and a max 10. All right, and it works. So I'm now doing something a little bit different. I'm not giving it a YAML file, right? We can, however, get the YAML files. So this is the scaling, the command to create a auto scaling. We can also get HPA PHP Apache and say out YAML. When I do that, I actually get the YAML definition back, and I can use, you can output this, tweak this, and then reapply it. Here there's some more conditions and messages and stuff like that, which Kubernetes automatically updates. All right. So let's break PHP, right? So I'm going to do a kubectl get pods. Well, let's actually do the get HBA and then just watch it, right? And now in this command, I'm gonna run busybox, which is just a small thingy. And then I'm going to, one quick second, apologies. I missed a command now. So what we want to do is we want to scale up this autoscaler, right? We want to create some load to scale up PHP automatically. So I'm gonna just do a very bad thing, is we're gonna constantly do a wget on the actual PHP Apache deployment. So that's per default on the cluster locally exposed. So that's on this address. And so the deployment default is the namespace as service cluster local. And we're just gonna keep looping. And there you go. So we're gonna generate some load. Now, this takes a little bit of time to update because Kubernetes doesn't constantly ask what's your usage of CPU, what's your CPU usage. You can also configure these things a little bit on how quickly you want to act, but as you can see here, the target is 200%. It's a bit much, right? So let's Kubernetes just do its thing. And just sit back. Quickly gonna look at your questions for a moment. And as you can see, the replicas is scaled up to 4. So let's open another one to confirm that is actually true. Get pods, and voila, there's a lot of them. So it's now also scaling without our intervention, allowing these things to do its thing. So I no longer have to watch this all the time, which is beneficial for my night shift or my night rest. So I'm quickly gonna take a look at your questions and I'll hopefully answer a few of them. I'm gonna quickly go back to the presentation. Oh. I keep clicking the wrong button, sorry guys. There we go. So let's go back to this guy. Right, so that's the start. And then let's go to what we've had thus far. So any questions? And I'm gonna leave my contact information on the screen while I look at your questions. In case of on-prem, how can a load balancer be used? So yes, you can definitely use, for example, a load balancer you have on-premise. I'm not going to go too much in depth of this, but it is possible. As I said, there's going to be something a bit more about networking coming up. So I don't want to spoil that too much because that's definitely going to be tackled there. Another question, which is about pods in different namespaces cannot talk to each other. No, unless you define it like that with your role-based access. No, they cannot. As you can already saw, I had the role binding, which kind of gets around that a little bit, but yeah. Right, that's the questions I've had here. If I don't see them, I apologize. And if you have some problems, please go to either my LinkedIn, my email, whatever, to address these issues with me on the GitLab page as well. Yeah, and oh, there's another question. I have a colleague who has issues with Kubernetes autoscaling where it works but cannot keep up properly with the increasing load. How would I tackle this? So as I said, it has a min and max, right? So you could decide to make the max a lot higher, but that also costs money, right? So more processing costs more money. You can also scale up, for example, the CPU percentage. Imagine you set it on 50, which is very low, really. So imagine you would want to put it on 80. I can't really go into very detail because I don't know exactly what application this is, but send me an email with the exact details and I could help you out maybe. Another one, how services are different from namespaces. How services from different namespaces can communicate. Again, I'm not gonna want to spoil this too much, but it is definitely possible to configure that. So one of the next webinars which we are working on is going to how are you going to set up your Kubernetes cluster. So that includes services from different namespaces which may want to talk to each other. I generally would not do that. I would really utilize the namespaces for their intended purpose isolation. Another question, can you make auto scaling more aggressive so it scales up quickly? Yeah, as I said in my example, it does take a while. Well, a while. It's a matter of 5 seconds. I don't think I can respond as quickly as those 5 seconds, so it's still decent. But yes, you can configure it to be more, let's say, aggressive. These are all cluster administration tasks, so you could up your query time on your pods on your to scale up quicker, so to give their information a bit quicker. Which leads me actually quickly to something which I didn't point out. On AWS and your local, this won't work because it doesn't have the metric server installed. Metric server is something which queries every pod for their CPU and memory, for example. So you can configure that, yeah, definitely. Any other questions? I don't see any. So I'm almost at the end of my time as well. So I'd like to thank all of you for your attendance. Thank you very much for the questions as well. I like them. If you have anything else, please reach out to me, go to GitLab, whatever. Yeah, thank you. Thank you very much. I hope to see you, well, on the next ones. Thanks, guys.